Hi, in this problem, we are going to look at a trigonometric inequality. So we are given that cos power 5 theta minus sin power 5 theta is less than 7 times sin cube minus cos cube theta. And we are also given the range of theta, which goes from 0 to 2 pi with 2 pi not included. And we are being asked, what is the range of theta? Basically here, the question is, for what range of theta in this interval 0 to 2 pi is this inequality true, right? So there are several approaches to this problem. One approach is plain trigonometry. However, a better way to solve this problem would be to take advantage of a little bit of calculus, right? So what I would suggest is you pause the video and try it yourself, and you can see if you're able to get the question or not. I will now try to show you how you can approach this problem in a smart way, right? So if we look at this inequality, cos power 5 theta minus sin power 5 theta is less than 7 times sin cube theta minus cos cube theta. We can rearrange this inequality a little bit, divide by 7 on both sides, and collect all the sine terms on one side and the cos terms on the other side. You can write it like this: sin power 5 theta by 7 plus sin cube theta is greater than cos power 5 theta by 7 plus cos cube theta, right? So basically, this inequality is just a restatement of the original one, and we have to find the range when this happens, right? Now, the look of this inequality suggests that we can use calculus by taking advantage of a function like x power 5 by 7 plus x cube, right? If this was my function and my inputs were sine theta and cos theta, then these are the values of those functions, right? So let's investigate the nature of this function f of x. So if f of x is x power 5 by 7 plus x cube, f dash x will be equal to 5x power 4 by 7 plus 3x squared. And it is obvious because there is a fourth power of x and second power of x here. This is always greater than equal to 0, which implies that f of x is increasing. F of x is increasing in its domain, right? Or at least it is non-decreasing, right? So if f of x is increasing, then we know that f of x1 is greater than f of x2 if and only if x1 is greater than x2, right? So this function will increase, or one particular value of the function f of x1 will be greater than f of x2 if x1 is greater than x2. And how do I connect it to a trigonometry problem? I will say that this side here is f of sine theta, and we are saying f of sine theta is greater than f of cos theta, and that will happen on this function only if sine theta is greater than cos theta, right? If sine theta is greater than cos theta, we will have f of sine theta will be greater than f of cos theta because the function f is increasing, and that is a much easier inequality to solve. We don't have to look at any trigonometric identity. We don't have to try to cancel factors or factorize this, which would be annoying. And you will simply use calculus and increasing functions to come to this conclusion. Now, the rest of the question is pretty obvious. How will you find the range where sine theta is greater than cos theta? You can draw the graph and find the interval in 0 to 2 pi, or you can find the general solution. I will just say the general solution here for sine theta greater than cos theta is 2k pi plus pi by 4 is less than theta, and till 2k pi plus 5 pi by 4. How do I know this? You can just draw the graph of sine and cos, and you will get the sense where sine is bigger than cos, right? So sine is bigger than cos in this portion. This is my sine curve, and this is my cos curve. Sine is bigger than cos after pi by 4, and it is bigger till here, which is 5 pi by 4, right? So pi by 4 to 5 pi by 4 is my range inside the 0 to 2 pi interval, whereas this is the general answer for this inequality, right? So the question becomes really simple, where you are employing a little bit of calculus and a clever choice of your function, and we can avoid trying to solve it directly through trigonometry, and we are utilizing our knowledge of calculus. Hopefully that will teach you something and you'll be using this concept in future problems. So that's it for this video. I'll see you next time.